Hello, my dear friends. This is Rajesh Mohapatra. I hope all of you are doing well and happiness. In this session, I'll be telling you about the concept of cloud storage. I'll explain more details about the cloud storage type like file store, cloud storage bucket, persistent disk, and local SSD so that you can easily understand it. Apart from this, I'll give some example for each cloud storage so that you can implement in your project based on your requirement. Let's get started. As you can see here, there are four main storage options like persistent disk, local SSD, file store, Google Cloud Storage Bucket are available for Google Cloud Compute Engine. Let's discuss one by one so that you can easily understand it. As you can see here, Google Cloud Storage Bucket. Google Cloud Storage Bucket is a container for storing and organizing your data in Google Cloud Park. You know guys, it is an object storage that allows you to store and retrieve any type of data including files, images, video and backups data. Buckets are basic container that hold your data. Everything that you store in cloud storage must be contained in a bucket. You can use bucket to organize your data and control access to your data, but unlike directories or folder, you cannot nest bucket. There is no limit to the number of buckets you can have in a project or location. When you create a bucket, you give it a globally unique name and geographic location where the bucket and its contents are stored. Google Cloud Storage is an object storage system, which means it stores data as object rather than the hierarchical file structure. Each object is identified by a unique name. You can control access to your bucket and its contents through IAM policies. You can also set the fine-grained access control for individual objects. As you can see here, types of storage classes are standard storage, nearline storage, coldline storage, archive storage. I'll give you some overview for the storage classes and we'll discuss more details for upcoming cloud storage session. Standard storage is the base data that is frequently accessed and stored for only brief periods of time. There is no minimum storage duration for the standard storage class. You are billed for the amount of data stored and the time it is stored. Nearline storage is a low cost, highly durable storage service for storing infrequently accessed data. Nearline storage is better choice than standard storage in scenario where slightly lower availability, a 30-day minimum storage duration and cost for data access are acceptable trade-offs for lower at rest storage cost. The minimum storage duration for nearline storage is 30 days. You remember it guys, this is very important for your GCP examination. If an object is deleted or overwritten within the first 30 days, you are still charged for 30 days of storage. Coldline storage is a very low cost and highly durable storage service for storing infrequently accessed data. Coldline storage is better choice than standard storage or newline storage in the scenario where slightly lower availability. You know guys, the minimum storage duration of coldline storage is 90 days. If an object is deleted or overwritten within the first 90 days, you are still charged for 90 days of storage. Archive storage is lowest cost, highly durable storage service for data archiving, online backup and disaster recovery. Unlike the coldest storage services offered by the Google Cloud providers, your data is unavailable within milliseconds, not hours or days. Archive storage also has higher cost for data access and operation as well as 365 days minimum storage duration. Archive storage is the best choice for data that you plan to access less than once a year. The minimum storage duration of archive storage is 365 days. If an object is deleted or overwritten within the first 365 days, you are still charged for 365 days of storage. As you can see here, persistent disks are good choice for storing data that needs to be accessible to VM such as operating system, applications and databases. They are also good choice for storing data that needs to be durable and highly available such as customer data and financial record. As you know, persistent disks are designed to be highly available so your VM will have access to their data even if there is a maintenance event or the disruption. Persistent disks are replicated across multiple zones so your data is protected even if there is a hardware failure in one zone. Persistent disks offer good performance for wide range of workload. Persistent disks can be attached to any VM and they can resized as needed. Whenever if you want to resize your persistent disks based on your project requirement, then you can easily resize it. To use persistent disks in Google Cloud Platform, you first need to create a persistent disk. You can do this using Google Cloud Console, Google Cloud Command Line tool or the Compute Engine API. Once you have created a persistent disk, you can attach it to a VM. Once a persistent disk is attached to its VM, it appears a block device on the VM. Then you can use the disks to store data such as operating system, applications and databases. As you can see here, the persistent disk can be divided into two types. One is zonal persistent disk, another is regional persistent disk. Let's discuss zonal persistent disk first, then later I'll discuss regional persistent disk so that you can easily understand it. Guys, zonal persistent disks are tied to a specific zone within a GCP region. This means they are available in single data center within a region. They are designed for highly availability within a single zone. Google replicates data within the zones to ensure durability in case of hardware failure. Zonal persistent disks are suitable for workload where high availability within a specific zone is sufficient. They are often used to applications that do not require redundancy across the multiple zones. The benefit of zonal persistent disks are generally lower cost compared to the regional persistent disk and well suited for workload where high availability within a single zone is acceptable. It is not suitable for workload that require redundancy across the multiple zones. On other hand, the regional persistent is available across all zones in a given region. This means they provide the redundancy and availability across the multiple data center within a region. Data retained to regional persistent is automatically replicated across the multiple zones in a region. This provides the higher level of redundancy and protection against zone failure. This is the advantage of regional persistent disks. Regional persistent disks are available across all zones in a given region. They provide the redundancy and availability across multiple data center within a region. It's suitable for applications that require the continuous operation even in the event of a zone failure. I hope now guys you understand what is the basic difference between zonal persistent disks and the regional persistent disks. Basically, the zonal persistent disks are tied to a specific zone within a GCP region, but the regional persistent disks are available across all zones in a given region. As you can see here in the Google Cloud Platform, there are two types of regional persistent disk. As you can see here, the standard persistent disk and the SSD persistent disk. Standard persistent disks provide a balance between the performance and cost effectiveness. They are suitable for a wide range of workload that do not require high level of input-output performance. Standard persistent disks are designed for a general purpose use and offer a mixed input-output operation per second. Standard persistent disks are appropriate for most workload that do not have strict performance requirement. It is not being suitable for high performance IO intensive application. If your application has moderate IO requirements, you are looking for a cost effective solution, then use standard persistent disks. SSD persistent disks are designed to deliver a high level of performance compared to standard persistent disks. They are ideal for applications with a high input output requirements. Guys, SSD persistent disks offer significantly higher input output operation per second IOPS and throughput compared to the standard persistent disk. They are optimized for low latency and high performance workload. Standard persistent disks are suitable for databases, analytic and high performance computing. If your application demands high level of input output performance, low latency and rapid data access, then use SSD persistent disk. As you can see here, the local SSD. SSD stand for solid state drives. Local SSD are a type of temporary high performance and physical attached storage option available in Google Cloud Platform. They are designed to provide a very low latency, high throughput storage for workload that require extremely fast read and write operation. Guys, local SSD are temporary. This means that the data stored on local SSD is not persistent and will be lost if the associated virtual machine or VM is terminated and undergoes maintenance or experience or unexpected failure. Local SSD offer extremely high performance and low latency access compared to other types of storage in Google Cloud Platform. This makes them well suited for applications that require rapid data access. The local SSD are physically attached to a host machine that is running the VM. This direct attachment contributes their exceptional performance. Local SSD are commonly used in applications that require intensive computing and fast data processing. They are suitable for data intensive tasks such as data analytics, machine learning, and real-time processing. Local SSD can be used as a cache storage applications to improve read-write speed. Local SSD are not persistent. It's crucial to have a strategy for backing off and persistently storing any critical data that needs to be retained. As you can see here, some of the scenario where the compute engine does not persist the local SSD data, like if you shut down the guest operating system and force the VM to stop. If you configure the VM to be primitive, the VM goes through permission process. If you configure the VM stop on the host maintenance event and the VM goes through a host maintenance event, that scenario compute engine doesn't persist the local SSD data. Guys, I hope so. Now you can understand what local SSD storage is. It. File store are fully managed service, which means that Google handles tasks like maintenance, scaling, monitoring for you. This allows you to focus using the file system rather than managing the underlying infrastructure. File store is managed file storage service provided by Google Cloud Platform. It offers a fully managed network attached storage NAS solution that allows you to easily set up and scale shared file system for your application. File store is available in multiple regions, allowing you to deploy your file system in proximity to your compute resources for reduced latency. The standard file store offers the high performance and is suitable for a wide range of workload. File store is compatible with a variety of Linux-based applications and workload. It supports NFS v3, NFS v4, WAN protocols. As you know guys, you can create snapshot of your file system which serve a backups that can be used to restore data in case of accidental deletion or other data loss events. File integrates with Google Cloud IAM, Identity and Access Management, allowing you to control access to your file system and set permission based on roles and policies. File Store offers a pricing model based on storage capacity and performance level. It provides a cost-effective solution for shared file storage. As you can see here, File Store has the following the principal use cases like application migration. It can be used to provide a file storage interface to application. Media rendering. It also used to reduce the latency while the media rendering. Electronics design automation. Data management is one of its premium features. Data analytics. Analysis of data can also done to get boosting insight. Managing and serving web content is made simple by the use of file store. I hope so guys. Now you can understand what file store exactly. File store is fully managed service and which means Google handles tasks like maintenance, scaling, monitoring for you. Guys, I hope so. Now you can understand what are the storage option is available in Google Compute Engine. Based on your project requirement, you can use it. Thank you and have a great day.